Okay, we're looking at quadrilaterals today and the sort of angles contained within them. So we looked at triangles last week. Basic things are, I think I sort of proved this to you with the triangle last time, but if you take any quadrilateral, then what you can do, let's just draw the angles on, let's call them A, B, C and D, like this, just to prove that it's not actually a magic trick. Then what you can do is, if we sort of tear this shape up, we're looking at these actual external angles. If we tear the shape up and then so that we've got each angle individually, if we put them all together, you will see, hopefully, that they make a rather perfect, ta-da! That's a really bad example of it because you can sort of hardly see them in my hands. They make a rather perfect 360 degrees. There you go, you can sort of see it like that. So that's a fact that we should bear in mind all of the time here because it will help us solve the problems that we've got. Another fact to bear in mind is that any quadrilateral is actually just made up of two triangles. So that can help us think about the 360 degree point, because we know that the angles in a triangle are going to be 180. So when you get a quadrilateral like this, which is two isosceles triangles, we know that this would be a right angle because it totally looks like one. And we've got 45 and 45, and we could have worked it out that it must be. So we can flip that round, and actually we can start to work out these angles from what they must be if we know this one here. Because let's say this one is 100, then we can work out what those two angles are and then add them all together will be 360. So that's my next thing. Again, it's all about quadrilaterals, internal angles being 360. Final thing, when you have a parallelogram, or I guess sometimes called a diamond, it would also be a shape that has two pairs of parallel sides. If you have a shape like that, then the opposite angles, this one and this one, are always equal. The opposite angles here, this one and this one, are always equal. So if this was, let's call it, what must it be? Let's say that one was 100. Then this one must be 100. Absolutely has to be. Also, if that one was 100, this one must be 80, because the two of them together, if I tore this off, the two of them together would make a straight line going along the top, and that would be 180, because that's what the straight line of a protractor is. So they're the sort of three tips that I want to give you. There's a bunch of questions to have a go at. They're all about angles in quadrilaterals, but with those few rules you should be absolutely fine to have a go at them and work out everything that they've kind of asked you. Remember, those little arrows, sort of little arrows between two lines, show that they're parallel. If there's two little arrows, it just shows a different set of parallel lines. Good luck with that. Any questions on the blog?